Well, everybody, good morning. I got a couple of power supplies I'm going to do a bench test with here. I got this Agilent 3620A and an Agilent 3610A that I recently purchased off eBay for pretty decent prices. Both units were, significantly under $100. They were sold as, repair parts, can't test, those kinds of things. So today we're going to bench test these two power supplies. We're going to use this HP 400E to measure the power supply rail noise, and we're going to use a HP 6060B electronic load to load these power supplies down. And likely I'll also use my Tektronix 2465 to measure the transient performance of these power supplies. This one here is a dual output power supply, dual 25 volt at 1 amp outputs. It has these 10-turn potentiometers on here, which is kind of cool. Nice, it gives you a nice fine control of the voltages. This one down here is just a single output, but you can select between two different ranges. You can select between 0 to 8 volts at 3 amps and 0 to 15 volts at 2 amps. And just like this one, it also has the 10-turn potentiometers for fine voltage control or current control. So with that, let's get set up and start testing these bad boys. Alrighty. Well, we got the power supply set for 25 volts. I've let this power supply run for about 30 minutes. I added the Fluke 87 so we could get a little finer resolution on the supply voltage. And with no load, we are showing, when I have this set for 25, we're at 24.96. Pretty damn good. And our noise level on the power supply rails is hovering around 30 to 40 microvolts. That is pretty good as far as I'm concerned. In the service manual states that the supply or that the noise on the rails should be 200 microvolts or less at full load. So far it's looking pretty good. So now let's add a little bit of a load. Let's add half an amp here. So I got that all punched in here to the load, so let's just turn it on. And our noise has jumped up to around 90 to 100 microvolts. That's still pretty good. The voltage didn't change, 24.96, so the regulation's still pretty good. The meter here is showing 530 milliamps, which is within the margin of error of my load, because the load's showing 520 milliamps. It's well within the plus or minus 75 milliamp specification for this electronic load. So we're looking pretty good so far. So let's now bump it up to an amp and see what happens there. So I'll switch over to the current input, set it for 1 amp. Still no drop in the on the voltage. Current is now up to 1.023 amps. Supply rail, or the noise on the power supply rails, I just barely went over 100 microvolts. So yeah, this is a pretty good power supply. So hey, so we'll go on to step number 2 here. All right, next step, we're going to introduce some transients. So what we're going to do here is that we're going to use the electronic load, and we're going to pulse a load at 1 kilohertz from half an amp to a full amp. It'll be 1 kilohertz at 50% duty cycle, so we should see a significant increase in rail noise. So let's turn the load back on, and right now we're just pulling half an amp. Once again, we're back up to about 100 microvolts of noise. So now let's turn the transient function on. And we're the meter showing here an average of 700 some odd milliamps. Still no change in the voltage, which is nice. And we're up to about looks like 550 microvolts of noise, which you would expect. So cool. That works for me. All right, let's try the other side of the power supply. It's got it set for 25 volts on the display. It's 1496, the same as the first one. We still have about the same amount of noise at no load, just below 50 microvolts. So let's turn on the load at 0.5 amp and see what happens. Virtually the same thing, slightly higher noise level, but hey, it's still very good. So let's bump up the current to 1 amp and see what we get there. And pretty much same thing. Noise level's up just a little bit higher on this side of the power supply, but it's still well within the 200 microvolt limit. So now let's go back to 0.5 amp constant load, and let's turn the transient function on. Let's see here. Whoops, I gotta change it to 1 amp. Oops, I know what I did wrong. Hold on a second here, guys. Okay, we need to set the current level for 0.5 amps. That'll make more sense now. Okay. I got the transient turned on here, so let's turn that off. Double check the transient level, which is set for 1 amp. Okay, now let's turn this back on. Should make more sense now. Yep, same thing. Supply voltage hasn't changed. This meter is showing an average, showing somewhere around 790 milliamps, and we have pretty much the same noise level, just below 550 microvolts. So I would say power supply is fine according to this, but we'll move on to test number 2. Alrighty, here we are with the transient response tests. Now I had to kind of compromise a little bit with my scope here, since it's an analog scope and the scope they use in the service manual is a digital. So I don't want to dig my digital out, so this will have to do. But as far as the service manual is concerned, the voltage, the amount of voltage, the pulse should be no more than 15 millivolts, and the recovery pulse on here is, according to my scope, is 14.5 millivolts. So we're barely within the limits. So now let's check the pulse width, and the pulse width needs to be less than 50 microseconds, and we're at 28.3 microseconds. So yeah, as far as that's concerned, I think that's going to have to do. So yeah, that's I guess we're all right there. Alrighty, supply number 2. Okay, this one here I got set for 8 volts, and we have it set for a maximum current of 3 amps. So we have a resting noise level of about the same, about 50 microvolts. Oops, I bumped this here, so let's try to get that back down to where it was. And according to the Fluke meter, it's 7.99 volts. Works pretty good for me. So let's load it down with 1.5 amps. So we'll set our current at 1.5 amps, and let's turn on the load here. Okay, our voltage hasn't changed, but we did go up to just below, let's see what we got here. about 140 microvolts of noise. Still pretty good. So now let's bump it up to 3 amps. See what happens here. Current 3 amps. We're doing just fine. No changes in the voltage level. And we have about 150 microvolts of noise. Not bad, not bad. All right, let's move on to the transient test. All right, here we go. First part of this test. Let's go ahead and turn the load on here. We'll set it for 0.5 amp. And once again, we're around 100 and just below 150 microvolts. So now let's turn the transient function on here. We'll be pulsing from 1.5 amps to 3 amps at 1 kilohertz. And as expected, our noise floor has gone up significantly. We're just below 800 microvolts. I would say that's pretty good. That's well within a range I would expect. Okay, well, this one here looks like we have about a 10 millivolts of regulation and a pulse width of about 25 microseconds. So yeah, I would say this power supply is doing just fine too. So yeah, I guess I got a good deal on all these. Well, so and there we go. A couple more power supplies to add to the collection here. These things make nice little bench supplies if you want something to just power low power electronics. These things work great. So yeah, not bad, not bad. Yeah, I've been finding these things all over eBay. They some of them are a little pricey, but if you're willing to take a gamble on one where someone just powers it up and doesn't know how to test it, well, you might get by with a good supply. There's not a lot that really goes wrong with these things, especially the if they're the Agilent branded versions. They're less likely to have capacitor issues just because they're a bit newer. Of course, if you can get them from Keysight, then you got something brand new. But the HP versions, nothing wrong with those. Agilents, they're just fine. So you got to kind of pick and choose what you want. Well, that guys, I think that's going to be it for now. I'll get some other projects going here down the road. So we'll catch you next time around. And hey, thanks for watching.